Thank you. Good morning, everyone. I just want to check if you can hear me. I had to put on my headsets because they've suddenly started constructing outside
Yep, we
without
can hear
warning.
you.
So,
Yep,
okay,
we can
I
hear you
hope you
and
can't
see the
hear
slide.
any of the constructions. Um, so as Sarah said, I am Edith, originally from Malawi, and my project here at the University of Leicester is focusing on the ecosystem services tools that decision makers will be using for different land uses. And today I'm going to be sharing part of my research, looking at how you can navigate those tools for mining land use decisions. So we have a challenge where we have competing land uses because mining doesn't operate in an empty landscape. It has to compete with other land uses like agriculture, water resources, um, rewilding itself, as well as the community priorities. And then this happens all in an environment where companies are facing increasing ESG and regulatory pressure to actually justify the decisions that they're making for their organizations. Now, um, this is all happening in an area of uncertainty, but then the mining sector does have frameworks that help them with that uncertainty to make things a little bit more certain, such as the UNFC, which is basically a global principle-based tool that is used for the classification, management, and reporting of resource projects. And this can be used at any level of production from exploration all the way to rehabilitation, depending on what project you're looking at. Now, what I'm focusing on here today is how do we feed into the E-axis? Because the NFC operates on three axes. The first one being the environmental, social, and economic viability, where we're looking at the cost of this project versus the benefit of it. It also operates on the technical feasibility axis, which is looking at what technology is needed for this project to go forward and how mature is that technology, and also the degree of confidence that we have in the geology. Basically, how much do we know about the resource that we're trying to work on in our project? So I'm looking at how do we fit into the E-axis? How do we create certainty in the environmental, social, and economic viability? Now, one way to do that is through using spatial tools, which could be ecosystem service focused, because these can quantify the environmental and social aspects of projects or decisions that we're making. They can help us to compare scenarios of what happens if we mine in this certain location and we remove some forest cover here, or how much of the forest cover do we remove in this area or put in a different area. And the end, this supports decision making, especially at the early start of our mining activities. Now, my focus has been to do a quick scoping review. So my quick scoping review has looked at the tools that exist and if they have been used or if they can be adapted to be used for land uses of agriculture, mining, and rewilding, with a focus on ecosystem services, where I'm looking at ecosystem services that would be valid and valuable for all three of these land uses, which are nutrient delivery, biodiversity impact, economic benefit, and carbon sequestration. And just a side note, all of these lovely pictures I've taken here are taken from where I'm doing my case study in Buckie in Scotland at a farm called Carnfield. And so this nutrient delivery picture is from a stream that passes through the farm. The biodiversity impact picture is from a ladybug that I happened to walk by as I was doing some water sampling. Economic benefit is literally just a farm field of barley at the farm, and carbon sequestration is some of the woodland that the farm has. Now, so through my quick scoping review, I was able to find a number of tools, but the more prominent ones have proven to be two: ARIES, which is artificial intelligence for environment and sustainability. This is a web-based platform that uses artificial intelligence, AI, and modeling to assess ecosystem services. So for ARIES, I have used the uh, K Explorer because it has a number of layers where you can be as detailed as you need to be. But I'm using the very first layer, which is supposed to be able to allow even the most um, non-expert user to be able to have an environmental impact assessment, an ecosystem services assessment. And here I was focusing on sediment delivery, which is basically how much topsoil gets moved into a water body. And this also would be able to inform how much of the nutrients that would be coming from things like fertilizer application end up in your water bodies, and how that later on is going to impact on the surrounding environment and how it's going to impact on water supply to the people. So for this tool, um, the inputs itself are here on the picture on the left. We can see this land cover, sea factor, contributing area. These are all maps that are linked to an open source database linked to the platform itself. So these are not inputs that you as the user get to define. These are inputs that already exist. Now, because of the way the system is set up, it's able to only model for either national level or regional or local authority. So in this case, I was only able to model for the whole of Moray, but then the little red dot there is actually where the farm is. That's where my focus is. So you can see how I have a bit of a large data set, but then my focus is literally just the one point. And from the scale that we could be able to see from the blue to the red tells us just how much of soil per tons per hectare would actually potentially end up in our water bodies over the course of the year. And lucky enough, it seems a lot of the region isn't in such high numbers because they all seem to be in the areas between about 5 to 10. So this was the first tool that I was able to look at. And the second tool is the integrated valuation of ecosystem services and trade-offs. Now, this is a suite of models that have been put into basically a package, and they allow you to model for different ecosystem services, as we can see on the picture here on the right. And this also allows us to have some scenario analysis where you're able to change different land uses and figure out, okay, what then happens if I change this piece of farmland here into possibly a mine, into possibly just a wild landscape, and it would be able to help you figure out, okay, this is what it's going to look like in the future, this is what it looks like now, and possibly a few years back, this is what it looked like. Now, for the inputs of this would be on the left. Here, you need to collect all of your inputs. And the only thing that the tool actually requires is that they're in the same projected coordinate system. So these would be GIS spatial-based inputs. You'd have a digital elevation model. You'd have basically a lot of maps of different things that go into the tool, and then you're able to produce the image on the right. Now, because I can define the area, and this tool is also based on catchments. So it looks at a river network, and it'll cut out a piece of all of the land, all of the cells that would therefore fit into the river networks in that area and give you basically a map. So here I'm able to define that, okay, this is the catchment I want to work in, and the red dot is actually where the farm is at. So this gives us a closer picture of what I want to look at as opposed to Aries itself. And we can see that from here, a lot of the areas on the farm particularly are below zero, as in about below zero of well, a little bit above zero, sorry, my bad. A little bit above zero of tons per hectares per year of potential soil that is being moved into the river system. And the lighter areas would be closer to 5 or 10. So after looking at all of these tools, what I've been able to glean is that the data drives the outputs. It depends on the input data quality and the local relevance. So for Aries, the data sources would be the linked open source databases, and these are global databases. And the scale is from a local to national scale. You cannot go below that. So some of the and this only means that some of the interpretations that you may get, they may not be as accurate as you would need, because firstly, the data is global data, and it's there are going to be some generalizations. There might be some gaps there as well, which would not be perfect for very site-specific modeling. Whereas in VEST, you get to define your data sources, you get to look for your data sources, get them to be as accurate or as detailed as you need them to be. And it's also operating at a catchment level, so you can make a catchment as big or small as you need, depending on the areas that feed into that river network. And this is important, especially when you're looking at if you're trying to make decisions for a mine of what to remove or what to put in a mining situation, because you need to know about the local quality of the data, the local context, and everything else that is involved in that. So at the end of the day, when you're navigating uncertainty in this area, we need to remember that the tools themselves, they will not remove uncertainty, but they can help you organize it. And we just need to be responsible about how we define the assumptions and the validations that we're using. We need to be transparent about what we're using, how we're using it, where our data is coming from, any gaps in the data, how are we going to validate this data, how are we making sure that this data is as accurate as it can possibly be, and just be transparent about the limitations of the tools we have and the data that we have as well. And so at this point for me, I think the next steps in my studies would now be to look at both of these tools and do some scenario analysis to maybe try to compare some different pieces of land, because maybe I may not have mentioned, but then the reason why I'm working on Current Road specifically is because this is a farm that has all three of those land uses I was talking about. There's agriculture production taking place, there is rewilding, there's a great woodland on the farm, and we also have mining activity in quotes because it's mostly quarries, but then this is something that could be, once we figure out which tool is best to use and how best it can be used, this is something that could be then be translated to other places that would have the exact same profiles, where you have to make a decision between your agriculture use, your mining use, or your rewilding use, and how best you can go about getting the most out of these uses for the environment, for the economy, and for the people. So thank you very much. That's all for me.
Fantastic. Thank you very, very, very much, Edith. Round of applause, everybody, for the fabulous Edith. And yeah, well, I mean, firstly, thank you very much for talking so beautifully about my home. So that's the farm where I grew up in the northeast of Scotland. And as Edith quite rightly says, we are very much exploring what are the best things to do with the land. My dad said to me a number of years ago, he said, if I didn't have to feed you lot, I would have looked after this land in a very different way. And I think, that's pretty interesting. And so whilst now we have lots of researchers and different monitoring tools everywhere across the farm, and my mum and dad wonder what on earth is happening, it is brilliant because it means that we can use this research to help change things with the land. And as Edith says, we are making changes and then able to monitor them to see if it's making a difference. So Edith, you mentioned comparing and contrasting with some other patches of land. Where are you thinking of looking or comparing Cairnfield to?
So at the moment, there's a farm that's pretty close to here in Leicester. It's called Ellerton Farm. And one of the reasons we'd like to go here is because they have a lot of data. So part of the validation process is looking at what the model is giving you and looking at what the actual data says from actual field sample collection to see if these are at least similar or in a range that is enough to give you confidence to say that, okay, these tools are actually as accurate as can possibly be. So one of the farms we're looking at is definitely Allerton, right here in Leicestershire, mostly because it's better than an 8-hour drive.
What do you mean? And what about home? Because I know that we discussed maybe you being able to do some research back home in Malawi as well.
Yes, so there's definitely potential for these tools to be used there. I think there's an area in where there's a new mining company as well, I think, in Lilongwe, where you have surprisingly very fertile soils, and the locals, I think, are not aware that the soils are so fertile because they have a lot of is it lime or something that makes it more fertile. But then there are some people there who are engaged in ASM, artisanal mining, who may not want to let the people know why their soil is so fertile because they're trying to access the rocks. So it would be an interesting thing to look at. Okay, so we have a hill that has this product. There's a lot of agriculture happening. There's some mining happening as well. But then we also need to protect the environment as well because it is in a very rural area. So how do we make this decision? How do we manage the land to use here in this area? So it's definitely an area I'd be interested in looking at.
Brilliant. And I think, I mean, this is one of the things that's really exciting about your research is almost being able to do the scenario analysis and say, well, what if it was artisanal and small scale mining first, and then could the agriculture then come in later? Or actually, is it better not to dig the rock out of the ground and to just lean in and optimize the agriculture? Or should we just leave the land alone? Because it has deeply significant cultural heritage significance, for example. I think that's really fascinating in terms of being able to use reproducible tools to assess what the difference in options might be.
Yeah, definitely.
Fantastic. Edith, one final question before we move on to our next fabulous speaker. And this comes in from the chat from Sadia, who's asking, what would you say is the most interesting or surprising thing that you found out about your study area with these tools? And I know that's difficult, me asking that to you.
So the most interesting thing I found about the study area is, well, the fact that using these tools, the results that you get, they're not the same.
Mhm.
And this could be a factor of the quality of the data that goes into it, because um, one of the farms that I was looking at the sediment delivery ratio was um, I was able to pinpoint that in this particular piece of land, one tool is saying that about 5 tons per hectare of soil is coming off of this per year, but potentially as runoff. And the other tool is saying that no, it's actually only half a ton. So it's you need to go back and look at the tools and say, okay, considering that activity that is happening here, considering that we're using tractors and the like, is this really possible? Is this feasible? Does this actually make sense?
Mm.
And then you need to start looking at, okay, what are the inputs? What's going into the tools? What needs to change? Does it make sense or not? And the like. So it's definitely surprising thing would be about the tools are different, the results you get are different. They're modeling for the same thing, but then because of the data that they have, because of the access that it has, you will get different results. Um, and I guess a very surprising thing would be that you would find peacocks up in Scotland.
Yeah, our next door neighbor has peacocks, which spend most of their time, I think, somewhere on our farm because I think there's more food for them. Brilliant. I think just, yeah, one final thing. So I certainly hope that the soil runoff isn't as bad as you're saying it could be. But that's also something from a farming perspective, things like making sure you're leaving vegetation or growing something on the fields all year round, etc. So something's there to hold the soil. Certainly, some of our next door farmers that are on very different soil types where it's much lighter, as soon as the wind blows, that soil disappears. Whereas we've got much heavier soil, it's got much more clay content, so it doesn't tend to disappear as quickly, for example. But it's really interesting from those tools. And I think final point on that, one of the things that we've been finding, there is some global biomass and effectively carbon stock tools that are out there. And we tested some of them because we've been measuring exactly, what is the biomass, what's the carbon stocks within the woods, within the bushes, the hedgerows, etc. And we've done this across 3 different farms in Scotland, including Cairnfield. And quite disturbingly, we found very different results in terms of how accurate the Planet Labs biomass tool was. And in one case, it was 2000% out. So it was overestimating that biomass by 2000%. That is a problem because if people are using this to help them understand where do you need to do offsets, things like that, if you've got some of these global tools that haven't necessarily been calibrated in the right way, that's then a problem. Not saying that they're bad tools, but they do need to be calibrated and anchored, or at least have the specific context so that you're talking about something that's a bit more real. But it's really exciting seeing some of your early results, Edith. Thank you so
Thank
much.
you.
Everyone, please put your hands together for the fabulous Edith. Round of applause. Brilliant.